Hey guys, thanks for tuning in. Today, we're gonna unbox the CR-10s Pro. All right, let's open this up. So this is basically the same as a upgraded version of the CR-10s, and it's packaged even better than the original. Hey, Chris?
What up?
Perfect. Can you give me a hand?
Sure.
This thing is too big for me to lift out on my own.
Put it down.
Just grab the packaging here. Should be able to lift it straight up.
There we go.
All right, and perfect.
Pretty nice.
All right, thanks.
Excellent job cutting the tape, by the way.
Thank you. All right, so it's basically packaged with two large foam blocks on the sides. And I think the best way to get this off is just slide it off the end. Okay, this one. So this is reminiscent of the CR10, or CRX, sorry, where you don't have the box anymore. Everything is built into the base unit. Two main parts. You've got the gantry here, which goes like that. We'll bolt it in a sec. Everything else is basically assembled. On the hot end, you have a sensor here, either capacitive or inductive. We'll find out in a moment. And we'll need to open this box to start assembling it. So in typical Creality fashion, they've given you a starter roll of filament. It's white, I believe it's still by CC Tree. And then we have our box of components for assembling. They include a micro SD card and a reader, USB cable, warranty card. This actually looks like a feeler gauge. Power supply, the standard Creality /Ender 3 style spool holder, and scraper, and all the tools you're going to need to assemble it. They also included a spare PTFE tube, and this looks a lot like Capricorn tube. They say it's an imported tube, but I'm not sure if it's truly Capricorn, but definitely feels a lot more rigid than the standard white PTFE they used to include. Another thing that I noticed as I was kind of looking at the sensor again is they've redesigned a bunch of the hot end assembly. They're using a radial fan now, looks like a 40-20 radial fan, still a standard 40-10 cooling fan for the hot end. The hot end heater block has a silicone sock installed, and along with the new radial fan, they've got in this case it's 3D printed, they've got a redesigned fan shroud that looks like it directs the air a lot better than the standard Creality shroud that they've used before. There's also a lot of improvements and changes to the extruder assembly area, but we'll cover that in more detail when it's upright on the base. The base is now using a ribbon cable like they did on the CRX to connect to the side of the extruder assembly there, which then leads to the hot end area. So I think the first thing that we should probably do from an assembly standpoint is we'll throw this on top, like that. Make sure that we've got enough clearance between the hot end and the bed. Move this up a little bit. And then there's these little cutout notches that kind of sits right in. And then I will hang half the printer off the back of this table, very carefully, and then find the M5 bolts that bolt up through the back. So we've got 4 M5s here. It's the only M5s in the package, so that must be them. A little bit shorter than I expected. And let's get our Allen key. We've also got standard snips that they all seem to come with. All right, so we're going to use 2 of these M5s in the bottom of each of these uprights, bolting through the base. All right, 2 down, 2 to go. So inside the base, just like on the CRX, they've got little foam guides, so you don't have to worry about losing a screw inside the base. There's channels that will lead it right up to the holes where it has to go through. So on the first side, I didn't tighten them fully, just so that I had a little bit of adjustability in case things were a little bit out of whack. Now that I've got the other 2 in, I'm just gonna tighten these the rest of the way. It is a lot heavier. I mean, there's a lot of metal in this base in comparison to the normal control box that they used to use. May as well go and connect this cable right now. It is keyed, so it can only go in one way. There's these little arms that you kind of open up. They latch onto the cable so that it doesn't slide out inadvertently. So just line that up and they'll grab on there. All right, I'll take a moment and talk about the extruder assembly here. So this is the filament runout sensor. Before, that was just a kind of press fit plastic bracket that didn't really stay secure and was a little bit finicky. So now it is completely bolted to the anodized aluminum or metal assembly here. It's got an inlet for the filament that doesn't look like it's large enough for any PTFE tube. So hopefully over time that doesn't wear a little groove into it. That was really common with the plastic extruder levers on some of the models. So if that starts to happen, I might have to drill that out and maybe add some PTFE. But they've made a significant change to the extruder assembly here. It is a dual drive gear, so it's got teeth on both sides, and there are gears at the bottom that kind of keep the 2 in sync, so they're turning in sync. So it should get much better pull on the filament and less chance for under extrusion or slippage. They've added little zip ties to keep pressure on the collar here to make sure that this stays in there secure. And everything here is metal. There's no plastic components whatsoever. The bed, looks like they've moved away from using the ultra base style beds. So this on, say, the CRX, or even on some of the Ender 3s now, they're offering the, it's kind of like an ultra base. It's got some sort of a grid-like coating on it. It's supposed to have really good adhesion with no extra adhesion promoters required. This is similar to the original build-tack type material that they were using on the Ender 3s, maybe not quite as rough. And that is bonded to a glass plate that's held on with these nice clips that they used on the CRX that just rotate at the front, and they're stationary at the back. So the glass plate just slides out the front when these are undone. We'll see how that works out for us. Hopefully this bed is nice and flat, so we'll take a straight edge to it and check that as well. They're using the large knobs that they started using on the Ender 3, and they're now offering on the CRX as well as this. We have a couple more connections to make here. So obviously we're still dual Z, so we've got cables for each of the Z motors. And I know one of the complaints that I heard about some of the early releases of the CRX was that the holes that these cables came up through were rough and jagged. These are both finished smooth holes. And there's a grommet here for the bed cable coming out the back, so there's no sharp edges for it to catch on. Your Y limit switch is back here, and it's already pre-connected, so you don't have to worry about connecting that one. So now really all that's left to do from an assembly standpoint is to attach the filament holder to the top. I know a lot of people don't feel good about having the filament on the top of their printer. They'd like to have it off to the side. You're gonna have to print a different type of holder for that. Myself, I've seen no real problem with it on top. So a couple parts to do this. There's just these large like nuts go onto the end of the tube. And then I like to put it this way. I just find that the filament has a more kind of direct path. If you put it like this, then your roll is going to be kind of in front of the printer and have to curl around. 6 of one, half dozen of another, really. To do that, there's this one little bag with 2 T-nuts and 2 screws. We'll use those to bolt that onto the top 2020 rail. Easiest way to do this, just thread the T-nuts on loosely, really loosely, and then we'll line them up with the groove in the top. And then as we tighten them, they should rotate if we're lucky. The other thing is, just from an appearance standpoint, I'm going to rotate the direction that I put this on. And lose a T-nut in the process. Just that way there's the finished side facing forward instead of the recessed side. Okay, before we try to print anything, there's a couple things we want to make sure of. We want to make sure that all of our wheels are contacting the extrusions so that when we rotate any one wheel, the entire assembly moves. The hot end in this case, surprisingly, is tight. If it wasn't, the bottom wheel has an eccentric nut. And then the same thing on the bed. There's usually a little bit of play in the bed, but again, in this case, there's really not. And the way that this bed is designed, it's kind of difficult to reach all the wheels. You're only going to be able to reach the outside wheels, but if I rotate, see this one's a little bit loose, I can rotate the wheel without moving the bed. So the outside wheels, there's 2 of them, one on the front and back of each side. They're going to have eccentric nuts on those, so you can tweak that a little bit to put a little bit of extra pressure between that wheel and the extrusion, so that when I rotate it, the bed is moving back and forth. They include this acrylic, I've now peeled the brown tape off of it, but a little acrylic block here. This is a 100mm block, and it's to make sure that your X gantry is level or parallel with the base. So the idea is that using your hands, you slowly rotate these couplers on the motors, raise it up, place the block in there. I like to hold it flush against that bracket, raise it, or lower it, sorry, until you contact the block. And then move it to the other side. You can see there's a little bit of play there. So I want to hold this side stationary. I'm going to hold that coupler. And with this hand, it's a little tricky, I'm going to reach my thumb around the back and rotate this coupler so that this side goes down and touches the block. There. So now my gantry is a lot closer, at least, to parallel with the base than it was before. So I'll take a couple minutes and just check these eccentric nuts. I know this one needs to be done. There we go. And on this side, yeah, just the back one. There we go. So this one wire for the one Z-axis motor here is a little raised and it's catching on the wheel. So just be sure you kind of tuck those in just to make sure that that doesn't happen. You'll be wondering why there's imperfections in your print. There we go. It's probably a little bit easier to do before you've plugged them in. All right. And now I think we're just about ready. So we're going to feed the filament through the filament runout sensor. It's always a good idea to cut it on a bit of a 45. Make sure that this segment of filament is as straight as you can make it instead of curved. And then feed it through the second hole, which is in the lever here. Try to turn this around a little bit more. So there's another hole in the side of the lever. Depress the lever. With any luck, it'll go into the Bowden tube. There we go. This lever is a little bit finicky. If you push too hard, it gets caught, and if you're not pushing hard enough, it's contacting the drive gears. We'll feed that all the way down into the hot end. Okay. So I think we're ready to plug it in, power it on, and we'll go through an auto bed leveling routine and then maybe start this print. So in with this 100mm block was the feeler gauge. It's labeled as 0.2. I'm going to say that's 0.2 millimeters, so 1 layer height or so. I'm going to assume that they want us to use that to check the clearance for the nozzle. I may just go with the traditional paper method, but we'll see how that works out. So let's turn this on, and we will go through the menu system a little. So I've powered it up. It did a little bit of a jingle, and before we go much further, I'm just going to throw the micro SD card in the slot on the side of the printer. So we've seen this before on the CRX. Luckily this time it's in English, so we see the hot end temperature here, bed temperature here. We can go into the temperature menu. We'll manually set the temperature. We're going to set the heated bed. We could say 55 or so, which is a lot nicer than like a rotary encoder for setting a temperature. That beep noise gets tiring, so in the settings you can get rid of the beep. So we have disable motor. If you're ever going to move anything manually by hand, you should probably disable the motor first. Language settings, we're not going to touch that. We can manually move each of the axes, so this is a good idea just to check mechanics. Bed moves forward, back. It's interesting. The X won't move backwards because we haven't homed it, so it doesn't know where home is. It's likely just assuming that it's already at 0. So if we home all the axes, and now to home the Z, it's moving to the center so that it's sure that it's on the base of the printer and not off an edge. So it just did 2 probes. The second one is much slower than the first to get you a higher degree of accuracy. I don't know if you've noticed, but it's very quiet. The stepper motors make no whining or buzzing so far, which is a nice improvement. I'm curious which drivers they use. So if we go to the print menu, it will show you what's on the SD card. In this case, it says 1 of 5 pages, but it doesn't show any files on the SD card. So this is something that we also saw with this menu on the CRX. The printer only displays the files that are on the root of the SD card. So these files are likely in a subfolder. It doesn't even show you subfolders, so we're going to have to plug that into our computer using the micro USB to USB adapter that they gave us, and we'll have to move those files into the root. So I've moved the G-code file, not the STLs that are on the SD card. There's a couple Chinese labeled folders. Inside one of them is something called a folder called modal, model spelt incorrectly. And in there is an STL file and a G-code. Just move the G-code file. It's a test dog print. So there we are, test dog. It's got a little G for G-code, so that's already pre-sliced. Ideally, that should be optimized for this printer. So we'll use that as a test print. Before we do that, I've already homed all the axes. So I just want to verify how well the auto bed leveling went. To verify the bed leveling, I'm going to set the Z axis. If you go to the settings menu, go to move, press on the Z axis box, and it will bring up a keypad where you can type in the position you want to go to. I'm going to bring it to 0.2 millimeters, which is the same thickness as this is labeled. And I should be able to slide this just under the tip, and there is just enough friction there that I can feel the vibration of like the fans against this strip. So that seems like it's pretty spot on. We can also check that at different areas of the bed. So I could move the nozzle, say, to the front, and I'm still at 0.2, and it's pretty darn close. So that's what we would hope. We also haven't done an auto bed leveling, which is like a mesh, 3x3 or 4x4 grid, so that it can take into account any of the pitch or yaw of the bed if it's out of whack a little bit. So under the settings menu, we'll go to leveling, and it even shows you the different measurement points in the grid. So it looks like it's a 4x4 grid here, which is kind of nice that they display that information on the screen. You can usually issue G-code to the printer to get the this report out of it. So it looks like it's just homing in the center. There we go. And so right now at the top it says auto leveling is off. So let's try turning that on. And let's hit the, where's auto leveling? I think that the button's labeled measuring. I'm wondering if that's auto leveling, because AUX leveling has the knobs in the picture. So we'll go, there we go. So that was right. So now auto leveling shows you the 4x4 grid. They're numbered 1 through 16. It's going to do a probing sequence, probably 2 probes, I would assume, maybe 1 at each point. And it will build out a mesh bed leveling report so that it can account for any kind of bow in the bed or dips, or if it isn't quite level from side to side, it will be able to software compensate for that as it goes around. I've confirmed that this is a capacitive probe, which makes sense. We're going through glass and then aluminum. It has a very small sensing distance. If you're using an inductive probe against aluminum, they're designed for ferrous metals. And even the fans on this are a lot quieter than previous models, at least so far. I do have the bed heating up right now. It's ideal to do any leveling with a hot bed. Even though we're not really using the nozzle, we're using a probe right now, the bed does expand and contract with heat, so I'd like to account for that as much as possible. Good stuff. And now I'm just going to gently, oh, it's moving on its own. That's nice. It's actually nice that it returns to home or to the middle like that. So here's the report of the difference that it found at the various points of the bed. So I would usually include a G29, which is auto bed leveling, in my startup G code, so that this kicks off automatically before every print, so I don't have to remember to do this manually before I'm using the machine. Or you could just do it on the screen if you so wished. So before we do our first test print, I do want to open the bottom of the printer now that I know that everything is working. Open it up, take a look at the power supply. It should be a Meanwhile power supply. I believe it's 24 volts now, which is kind of becoming more of a standard, thankfully. It's nice because you don't need as thick of gauge wire to run a lot of current through it. You're running less current at a higher voltage. One thing I should mention is when I was using the 100mm block to level those sides, I was having a difficult time initially, and there are 2 threaded couplers that these threaded rods go through that bolt onto these brackets. And this one here, both the screws had completely fallen out. So as I was trying to level the one side, there was really nothing attaching the rod to this bracket and therefore moving the assembly up and down. So I scrounged through the box and I found them in the bottom of the box and I bolted them back on. You want to leave these a little bit loose, but I tend to snug them up probably more than not. They do have lock washers on them, so there'll be a little bit of pressure put on there. The idea, I think, is that these are supposed to float to take into account any kind of wobble in this. There shouldn't be any, so there should be no problem in tightening those up. I definitely don't want them to pop off again. So keep an eye out for that in case that happens to you. But to get into the bottom here, I'm just going to tip it probably this way, watching out for the cable. There we go. And then we're going to have a series of screws in the bottom here. I don't believe we have to take the feet off, but we'll find out in a second. And then we will pop this entire bottom plate off and see what makes this tick. We are not going to use the flathead screwdriver that it came with. These are Phillips bolts, star if you will, so we're going to use a Phillips screwdriver. I don't want to strip any of these in the process, and that little flathead is just not the right size. So after removing a pile of screws, it seems, a couple in the side and a bunch on the bottom, we can remove this panel to expose the guts here. So we have a Meanwhile power supply, say 21 amp, 24 volts, so that gives us about 500 watts or so. Ribbon cable that we see coming out the side here. Here's the little foam guides for the screws that bolt into the uprights that I mentioned earlier. We have looks like a solid state relay for switching the bed. There's another radial fan here, the exact same one, looks like 4020, as we saw on the part cooling fan on the Hotend assembly. The board, kind of your standard Creality board, and a little beeper at the front, little buzzer. And so because this is a touchscreen, on the touchscreen board, you'll see a micro SD card slot. That'll be for upgrading the firmware on the touchscreen. And usually the firmware on the touchscreen has to match or line up with, according to the manufacturer's specs, with the firmware that you've thrown on the board. There's a nice kind of frame in here, 2040 on the sides, 2020 front and back, to kind of reinforce the structure of the little stamped steel assembly. And there's a exhaust fan at the back to bring out the hot air from the inside. The Y-axis, the belt is driven by this motor here that's underneath. And unlike, say, a CR10, the belt runs sideways instead of up and down like this. It's running this way. Not a whole lot else to show you under here. We will button it back up and flip it back over and get printing. All right, so we've buttoned it back up and we're ready to do our test print. We're going to print the test dog G-code that we were looking at on the screen earlier, and we'll see how that turns out. So hopefully you found that useful. Remember to like and subscribe and ring the bell to get notified when we upload more content. And leave us some comments down below. Let us know what you thought of this video and what you'd like to see in the future. Thanks for watching.